we'll try to look at some algebraic or matrix algebra, meaning manipulations. Okay, so not yeah. So we look at some manipulation of matrices. Okay, so now let's look at the first manipulation, which is I take two matrices. Okay, so let's say A is R m by n and B is R n by m. Okay, or to make it very general, let's call it as n by k. Then if I look at AB, right, so what will be the dimension of AB? N cross m cross k, right? That will be the dimension. So I can talk about the ijth entry of this matrix. Okay, so what is this? What will be the ijth entry? Can somebody guess or say something about ijth entry? How do you get ijth entry of the product of two matrices? How do you take the product? You take the row multiplied by the columns, right? How do you get the ijth entry? You take the ith row of A multiply by jth column, right? Is that fine? Okay. So now what we will do is, so the answer would be, you take ith row of A times jth column of B. Okay, this is as simple as this. So what is the ith row of A? So when you multiply two matrices, two vectors, right? So that's what I'm doing. I'm taking a row vector multiplied by a column vector, right? So what do I? If I do that, is that correct? Did I make any dimensionality mistakes? No. Okay. So fine. So what do you mean by multiplying a row vector by a column vector? You're taking the first element here, taking the product, second element, taking the product and summing them, right? So I can write this as, for example, ith row, but I'm going to take lth element, right? L goes from 1 to whatever. And I'm taking B. What should I do here? I should look at lth column, right? So whatever. And jth row. So I have to sum it over all L. L goes from what to what? J is the, so L is the number of columns, right? So this is N. This is fine. So the ijth entry is AIL, BLJ, summation over all L will give me this. This is very easy. Okay. Now, this is the first one. So suppose I look at what is trace of a matrix A? Sum of the diagonals. Okay, of course, this should be n cross n. Okay, otherwise trace is undefined. Okay, so this is summation I equal to 1 to n A I. Right, I'll look at the diagonal entries and add them. I get trace of A. So now let's look at what is trace of AB. Now, if I have to write this, then AB should be square matrix, right? Otherwise, trace is undefined. So this could be, for example, m cross n. This could be n cross m. Okay. Then the resulting matrix will be m cross m. So you have the trace. Okay. So what will be the trace of AB? All that I have to do is I have to take the diagonal entries of AB. So what are the diagonal entries of AB? So I know the ijth entry of AB, right? So this gives me the ijth entry. So I have to look at ith entry. So that's pretty easy. So L equal to 1 to n A L B L I, not J, right? This will give me ith, and you have sum over all I, right? So I equal to 1 to m, right? This will give me the trace. So keep this in mind. Okay, so get used to these things. Almost trivial, but you should get used to it. Okay. Okay, so any other things that you have seen? So one more last thing. So suppose I have two matrices A and B square. What is trace of A plus B? Yeah, it's trace of A plus trace of B. This is also easy. And then finally, trace of, suppose I have a scalar and what do I get? Alpha times trace of A. Is that correct? This is pretty trivial, right? Okay, fine. Okay. Um, okay, now let me ask, maybe I'll write this. So, what can you say about, for example, I have two matrices A and B. I'll take trace of AB, trace of BA. Of course, A is M cross N, B is N cross M. Here, B is N cross M, A is M cross N. So, BA is N cross N, AB is M cross N. So, what can you say about the traces of these two? Yes? Huh? Huh? Is it different or same? Hmm? Any idea? Those who are online?
So different.
Yes. Huh?
Both
Different?
are different.
So why do you say that?
Uh, so because the summation of I for the first one will run from 1 to m, and for the second one it will be from 1 to n. I mean, the
Okay, so
two.
let's try that. So whatever you are saying, right? So what should I do? A I L B L J, right? Is it J or I?
I
I. Okay. So I have to sum it over all L. L should go from the number of columns of A, right? So the number of columns of A will be N. And then I have to sum it over all I. I equal to what? The number
1
of
to n.
rows, right? So the number of rows will be M. Okay. So what happens to this case here? Same thing. B. What is this? I should start from B I L A L J. Sorry, this is I again, right? Right. So L goes from 1 to M, right? Remember. And this goes from I goes from 1 to N. Okay, now are these two equal? Huh? What can you say about this? Equal or no, not equal? Hmm? Question. Is it equal or not equal? Hmm? So what do we have here? So 1 goes from L equal to 1 to N. So A I L, right? In other words, I goes from 1 to N, right? So see, let's look at what is happening here. So let's use, so L is this part, right? This goes from 1 to N. Okay. Let's see whether this part goes from 1 to N. No, right? Is that correct? Yeah. So no, let me not do that. So now, how do you prove that both are equal or not equal? What do you think? Is trace of AB equal to trace of BA, or it's not equal? What? Hmm? So why? Right? So how do you show that they are the same thing? Okay, so let's, you are saying replacing I by? Uh-huh. Okay, so let's, this is equal to, you are saying I equal to 1 to M, L is equal to 1 to N. Okay, so I you are making L and L you are making I. Okay, right? Is that fine? Okay. Anyway, so let's not waste too much time on this. Check. Okay. Fine, but keep this in mind. Okay. So fine. Now, okay. So, okay, I think I pretty much covered most of the basic algebraic whatever. Okay, so one more thing. Suppose I take this vector, okay, so a1, sorry, not this. Okay, and I multiply it by another vector like this. So what do you get? Let's say this is n rows one column and this is one row n column. Okay, so what is the what do you get? You get a matrix, right? What is the dimension of a matrix of this matrix? N cross n, right? So now what can you say about this matrix? This is a very easy decomposition, right? So it says a column vector times a row vector. It's called outer product, right? So what can you say about this matrix? Maybe think about rank of this matrix, okay, to be very specific. What can you say about the rank of this matrix? Is it full rank? So let's ask this first question. Is it full rank? Yes. How many of you think that it's full rank? Raise your hand. Okay, how many of you think that it's not full rank? Something called rank deficient, right? So whenever it's not full rank, we will call it as rank deficient. So how many of you think that it's rank deficient? Only two? What about the rest? Don't care? Yes, so yes, Sumant. Hello, Sumant, you wanted to ask a question? Okay. How many of you think that it's not rank deficient? No? Okay, why do you think that it's rank deficient? Hmm. Hmm. Okay, so that's one way, but there is a simpler way, right? So if I can show that, for example, ax equal to 0 for some x not equal to 0, you are done, right? It should be rank deficient. That's what we saw. So how do you show this? Well, all that we have to do is I have to find an x such that b times x is 0, right? b1 times x is 0. So all that we have to do is, let's say b1, b2, bn times, I have to find something here that will give me 0. Can somebody tell me what is it that I have to fill in here? Okay, assume that this bn is not equal to 0, okay? I can always assume that. So what I will do is I'll put 1, 1, 1, 1 till here. The last one, right? I will do the following. So if I put 1, 1, 1, I'll get b1 plus b2 plus b3 till bn minus 1, right? So I have to subtract that. So what do I get here? I'll get bn times the last entry. Let me call that as some x bar. Okay, this last entry. That should be minus b1 plus b2 plus etc. bn minus 1, right? This is what I should get. So in other words, x bar should be minus b1 plus b2 plus etc. bn minus 1 divided by bn. So that's why I need bn not equal to 0, otherwise you cannot divide. So all that I will do is last entry, I will choose it this way. So when you take the product, you get 0. And this vector is definitely not 0 because you have 1 here, right? Do you agree? So it cannot be full rank, definitely. So what do you think is the rank of this matrix? We will probably revisit, or you can think about it later, okay, after a few classes. But what is the rank of this matrix? Rank 1. Why? I can always find n minus 1 orthogonal, whatever, so-called orthogonal vectors, right? So I haven't discussed about orthogonal vectors, but you can find so many n minus 1 such vectors, right? Okay, so it's actually rank 1. You'll be able to mathematically verify it once I discuss about inner products and so on. Okay, okay, so let's move on to how do you invert a matrix. Okay, then we will look at other transformations.